Aloha class, here we go, section 6.5. I would say it's probably the most fun of the lessons in 6.5, but it's kind of long, so we're going to break it into two separate sections, okay? Here we go. Let's go ahead and get started with this bad boy. All right, 6.5 notes, solving square root and other radical equations. So that word equations mean we're going to have an equal sign. Whenever we have an equal sign, it means we have to, whenever we're solving it, we have to get the variable by itself. Now, this particular one, if you notice our variable x, it's stuck underneath a radical. Now, if it's stuck underneath a radical, you're not allowed to get that x by itself until the radical is by itself. So if we have a problem like 3 plus the square root of 2x minus 3 is equal to 8, our first job is to get the radical by itself. So we look outside of that radical. The only thing outside of this radical is that 3. So I've got to get rid of the 3 first. How do we do that? It's a positive 3, so we subtract 3. So we get the square root of 2x minus 3 is equal to 5. Now the question is, how the heck do I get rid of that radical sign? Well, all I really have to know is what number is in the ditch. Okay, and there is a 2 in that ditch, right? An imaginary 2. And the way you get rid of it is you raise it to the power of 2. And if you do it to one side of an equal sign, you've got to even it out to the other side of the equal sign. And in essence, what we're doing here is 2 is the power. So remember, if we wrote it as a rational exponent, that means 2 goes up, and that's my root. And what's 2 divided by 2, class? It's itchy, right? Which in essence gets rid of the radical, and I end up with just 2x minus 3 to the first power, which we don't ever write it to the first power, right? That would be tedious. And then we get equals 25. And then we just plus tree, and we get 2x equals 28. And we divide by 2, and I get x equals 14. Now, the cool thing about math is you can always check to make sure you got the problem right. And for these problems, we're going to have to actually do that. Now, how do I check it? Well, you take that x value of 14 and you plug it in here, and you see if you get 8 as your answer. So let's check it. 3 plus the square root of 2 times 14 minus 3. Please excuse my dear Aunt Sally. A radical is a form of parentheses. So I got to do inside the radical first. 2 times 14 is 28. What's 28 minus 3? 25. What's the square root of 25? 3 plus 5, which is Hachi. It's 8. So we're good to go. All right. That's all you have to do for these problems. Okay. You do have to solve, but it is very important to check. But that is why math is so awesome, because you can check to make sure you get every problem right. All right. Do you got it? All right. Let's see if you guys got it at home. All right. Here we go. The square root of 4. Now, what I challenge you to do as we're both writing this down, or you're doing it in your notes, is to hit pause and see if you can get it on your own. All right. Here we go. Got to get the radical by itself. How do I get that radical by itself? Well, I have a minus 5 hanging on, so I'm going to add 5, right? Which gives me the square root of 4x plus 1 equals 5. Okay, the radical is by itself now, so all I have to know is what's in the ditch. A 2 is in the ditch, so that means I'm going to raise it to the power of 2, which gives me 4x plus 1 to the first power. 5 squared on the other side is 25. Little junior high math here. 24 divided by 4, I get x equals 6. Well, let's check it, because math is awesome and you can make sure you get every problem correct. The square root of 4x, so 4 times 6 plus 1 minus 5. And it says I have to get 0 as my answer. 4 times 6 is 25. 24. Got ahead of myself. But what's 24 plus 1? That's 25. Well, what is the square root of 25? 5. What's 5 minus 5? 0. Check, check. Good to go. All right. Now, the next page is just going to be a whole bunch of practice problems. We will do 2 of them just to make sure you guys are good to go. All right, here we go. We're going to do 9 and 17. All right, if we look at number 9 here, we get 3 square root of x plus 3 equals 15. Now, if I want to get that radical by itself, you notice a couple of things. You've got a 3 in front and a 3 behind. Which one do we get rid of first? Right? It's the way we've been always solving equations. Just pretend like you want to get the radical by itself. right? We would always subtract that 3 first, right? It's like SADMEP, that PEMDAS going backwards. You get rid of any adding and subtracting first. So you get 3 square root of x equals 12. Now that radical is still not by itself. We have a 3 in front, and it's 3 times the radical. So the way we get rid of it is we do the opposite, which is division. I get that, right? And then I just have to know, how do I get rid of the radical? Well, what number's in the ditch? A 2 is in the ditch. So I'm going to square both of those bad boys, and I get x equals 16. Well, you know what? I want 100% on the next quiz. So I'm going to check that bad boy. So let's do it. It says 3 square root of 16 plus 3. And I have to get 15 as my answer. 3 square root of 16 is 4. 12 plus 3. Sweetie sweet. Got it right. All right, here we go. I would say the toughest one on this page, without a doubt, is number 17. All right, so here we go. Square root 6 minus 3x minus 2 equals 0. Okay, I've got to get rid of the radical. I've got to get the radical by itself. So that means I'm going to add a 2 first on both sides, right? Plus 2 plus 2. I get the square root of 6 minus 3x equals 2. Got to get rid of the radical. What number's in the ditch? A 2 is in the ditch, so I'm going to square both sides. Okay, so I get 6 minus 3x equals 4. Remember, those guys kind of like 2 divided by 2 is 1. They cancel each other out. Now let's solve. Minus 6 minus 6. I get negative 3x equals negative 2. Divide by a negative 3. And I get x equals a positive 2/3. Now that's a fraction, which would freak some people out, right? Might be tough to check. But let's go ahead and use our skills here and check. I want it at 100% on the next quiz, right? So we're going to do the square root of 6 minus 3 times 2/3. That's all underneath the radical, minus 2. And I got to get 0 as my answer. All right, so here we go. Square root of 6. Oh, I got to multiply here. That's 3 over 1. So that'd be minus 6 over 3 minus 2. Well, 6 divided by 3 is 2, right? We always do the radical first. 6 minus 2 is 4. What's the square root of 4? 2. 2 minus 2 is sweetie sweet. I'm dominating today. All right, here we go. Does it get a little bit tougher? Man, I hope so, because this is getting nice and easy. Japon easy. Whoa, what? That says a 2/3 up there. Woo. So how do we deal with this bad boy? Okay, let's do it. Let's get it. All right, let's rewrite this problem. It's 3x plus 1 to the 2/3 equals 12. Now remember, a rational exponent is a form of a radical, right? I could actually rewrite this problem as 3. The number on the bottom is our root, remember, right, class? And then that's your power, equals 12. So I'm actually going to do this both ways because I think it's important to see it done both ways. First and foremost, you got to get the radical by itself. That's a radical. Okay, let's divide both sides by 3, right? That would be my first step. Let's get rid of that 3. This side here, you get this. Okay, this side over here, divide by 3, right? I'm going to get the same thing, but I'm writing the problem, one in radical notation, one with a rational exponent. And you guys can pick the way that you like the most to solve this guy. All right, now here we go. I'm going to do the right-hand side because that's how we've been doing it so far. I have a 3 in the ditch. Well, if I have a 3 in the ditch, how do I get rid of that 3? Well, I raise each side to the 3rd power. So that's going to give me x plus 1. Now, it's not to the first anymore, right? Those guys cancel out because 3 divided by 3 is 1. But look I have a 2 that's there, so I got to keep that there. And that's actually very important. And then I get 4 to the 3rd power. And 4 to the 3rd power is 64. Okay, now that's that side right there. Now, I have to get x by itself, and x is still stuck, right? It's inside, but it has a power of 2. So if it's a power of 2, how do I get rid of that, right? We square root both sides, right? If it's a 2, that means we square root both sides. And the square root of 64 is, what do I have to remember here? Whenever I square root both sides, right, class, I need to remember a plus or minus. And the square root of 64 is 8. So then I get x equals, because I'm going to Well, here, I'll go one more step here for you guys. I get that. Okay, so now I'm going to subtract a 1 on both sides, and I got to come this way a little bit. I apologize. -1 plus or minus 8. And whenever I have plus or minus, right, class, that means I have two answers. Okay, one of my answers would be x equals -1 plus 8, which would be 7. Okay, so that's one of my answers. And my other answer is x equals -1 minus 8, which would be x equals -9. And guess what? Both of those answers actually work if I went back and checked. Now, I happen to like this right-hand side because if we do it that right-hand side way, we do not forget about the very important plus or minus sign. Okay, now do they both work out? We're going to check it out right now. That's why I'm erasing. So we said 7 and -9. So I'm going to check this here before we do the left-hand side. So let's go ahead and check. Oh, snap. No, no, no. Okay, let's check that side, but I do want it to be blue to know that we're doing something different. So it'd be 3. Okay, so it'd be 3. Let's go blue. So it'd be 3. Let's check these. What was it? It was a 7. 7 plus 1 to the 2/3 equals 12. Whoa, it's got to equal 12. So we got our 3, okay? And then we have 7 plus 1, which is 8 to the 2/3, right, class? And then we handle with 8 to the 2/3. Now, what's 8 to the 2/3? Well, that means we're going to do the root and then the power, remember. Okay, so we're 3, and then we want to rewrite it as the cube root of 8. And remember, when I did these before, I said always put that square on the outside. Now, what is the cube root of 8? That's 2, so that equals 3. 2 squared. What's 2 squared? Please excuse my dear Aunt Sally. That's 3 times 4, which is 12. Okay, guys? And that one worked out. Now let's see if the other one works out, right? The other one said, let's do the same exact problem, but let's put a -9ers in there. Do you think both are going to work at home? Let's see if you guys were right. 3, -9 plus 1 to the 2/3 equals 12. Okay, guys? So -9 plus 1 would be a -8 to the 2/3. Whoops. We just want to know if it equals 12. Okay, so now we've got to rewrite this. Remember, that'd be 3. That's 3 is in the ditch. -8. Then you're going to square it. Am I allowed to have a negative if it's an odd root? Spling, spling. Check, check. I am, right? So then I bring the negative on the outside. Okay, and then remember the cube root of 8 is 2. So instead of +2, it's just going to be -2. But then you square it. What's -2 squared? It's +4. Did I get 12 as my answer? Oh, snap. I got 12 as my answer. So both of them work. How about that? Whew. It's a lot of work for one problem. Why do you think this is done in 2 parts? Okay, but now let's look at this. The reason why I like the right-hand side better is because you remember that very important plus or minus. When I'm doing it with this side, there's a trick. It's a shortcut, but if that's my exponent, the way I can get rid of it is raise both sides to the 3/2. Okay, but what you have to remember here is your root is an even number. And if your root is an even number, you have to remember that you're doing a plus or minus. So that actually would be plus or minus to the 3/2. Okay, and a lot of us would normally forget about that plus or minus, right? It ends up happening right here. And you guys are at home are saying, well, that's an 8 right there. Well, watch what happens here. Let's do 4 to the 3/2. Let's do it over here. I'm going to do it over here in red. What is 4 to the 3/2? Remember, 2 is the root, and that's exactly why we needed the plus or minus. And 4 is the power. So what's the square root of 4? It's 2. What's 2 to the 3rd? That is 8. So when I finish this one, I get x plus 1 equals plus or minus 8, which is the same exact thing as that. I just wanted to show you the 2 ways you could handle this type of problem. But if I were you, I would do it this way, because that way you are going to remember the plus or minus when you're taking an even root of both sides. Okay? All right, let's go ahead and keep on going. We're going to do another one, and I'm not going to do them both ways. I'm just going to do it the way that you probably should do them, okay? Which is good, which is in this format right here. So let's go ahead and do this one. It's 3. This time it's the 5th root of x plus 1 to the 3rd power plus 1 equals 25. Remember, we got to get the radical by itself. Well, how do I get the radical by itself? Well, we subtract 1 on both sides first. 3, 5th root of x plus 1 to the 3rd. Remember, you could put that 3 there or on the outside equals 24. Is the radical by itself? No, you still have a 3 on the outside. Since it's 3 times, we do the opposite, which is division. And I'm here right now. Get gaze? Equals 8. Okay, so now what do we do? Whew, this problem ends up getting really, really big. All right, but we're going to get rid of that 5. Well, how the heck do I get rid of that 5? Well, we get rid of the 5 by raising both sides to the power of 5. Now, 8 to the 5th power, oh my goodness, is that a super big answer? So since that's a super big answer, guess what? I'm going to say, hold on a second, because what am I going to do now? I am going to get rid of this 3. How do I get rid of that 3 if it's a power? I'm going to cube root both sides. All right, so let's now cube root both sides and cube root both sides. Now, if you remember earlier, let's come over here. Now, what do I have left? I have an x plus 1, right? Because if it's a 3 and a 3, it becomes 3 divided by 3, which is ichi, which is 1. And I get equals the cube root of 8 to the 5th. Now, if you remember, I could put that 5 on the outside or on the inside, right? So I'm going to be very smart here. And remember, a root makes the number smaller. The power makes it bigger. So let's go ahead and move that 5 and put it on the outside. And we all know what the cube root of 8 is. Oh, now if you notice for this one, you might have said it by home, Mr. T, you forgot the plus or minus. No, I didn't. Why does this one not have a plus or minus? Because that's an odd root. So you don't need the plus or minus. And then, so this one here, we're x plus 1. We all know what the cube root of 8 is. It is 2. And then we should know what 2 to the 5th power is. But if not, use your calculators, and you get 32 minus 1, x equals 31. All right, so that's a very involved problem, class. I know it's a lot to take in right now. I'm only going to do one more. Practice it in class, and then we'll do part 2 for your homework for the next class. Okay, guys? But what I would like to see you guys do at home for this next one is challenge yourselves, hit pause, and see if you can get the right answer on your own, okay? All right, so hopefully you hit paused. If not, hit pause right now. Come on, challenge yourself. You guys can do it. Equals 8. Now remember, I said there's 2 ways to do these. I highly encourage whenever you have a rational exponent to let's change it to a radical. So let's just rechange this problem. 3 is in the ditch, okay? That means it's going to be squared. That 2 can go on the outside or the inside, remember. But that is how I would rewrite it, right? You have your power and you have your root. Now, you got to get your radical by itself. So I have a 2 on the outside. That's 2 times. Well, how do I get rid of that? We divide it. So we now have the cube root of x plus 3 squared equals 4. Now, remember, we get rid of the radical first. How do I get rid of the radical? Well, you have to get rid of the root. What's the root? That's the number in the ditch. So this time there's a 3 in the ditch, so we're going to raise both sides to the power of 3. That'd be x plus 3 squared equals. Now 4 to the 3rd, we should know what that is. Like the other one, it was like 8 to the 5th. That's just enormous. But 4 to the 3rd is 64, so I'm going to simplify that. If you didn't want to, you wouldn't have to. But now I've got to get rid of that 2, and that 2 is a power. How do I get rid of a power? Well, you root it, right? You root it. What do I root it? Well, if that's a 2, you square root it. Well, if you square root one side, what do you have to do to the other side? Square root it. But what do you have to remember? It's a square root. That's an even root. Plus or minus. Okay? So here we go. So here we get that goes. That's 2 divided by 2, which is ichi. So it's x plus 3 equals plus or minus the square root of 64 is 8. Okay? And then we finish this guy. We subtract 3 on both sides. So it's negative 3 plus or minus 8. So that means I get 2 answers. What is our first answer? X equals negative 3 plus 8, which is 5. And x equals negative 3 minus 8, which is negative 11. And believe it or not, both of them are going to work. And you should get in the habit of going back and checking to make sure that they work. Now, I do want to show you guys one thing because I want you to get in the habit of getting good at it. 4 to the third wasn't very big, but I said you could have left it like that. Well, if I left it like that, what would my next step have looked like? And I want you to see, and it might be helpful to write it down. Right? It looks like that. But let's do this. It's very helpful to continue to get good at these. All right, so now I'm going to square root both sides. We know that. It's got to be an even radical. And if it's an even radical, I got to put a plus or minus. So we get x plus 3 equals plus or minus the square root of 4. Now, where did I say we were going to put that 3? Well, we always want to put that 3 on the outside. Okay, and then watch, class, what's the square root of 4? Well, the square root of 4 is 2, and then it's 2 to the third. What's that? That is hachi, or 8, right? Which that is the same as that, and it would finish it the same way. All right, but that's a lot to take in for a lesson. I am going to go to this next page, and I would challenge you guys to try maybe 1 or 2 of them. And the best thing about these problems is you can always check to make sure that you are correct. All right, alohas. We will see you in class. If this lesson was tough, and it should be, it's a pretty tough lesson to understand, make sure you guys are coming in for help.